In this video, we're going to continue our discussion of Chapter 3 by doing just a brief overview about deductive arguments. The defining feature of a deductive argument is that the truth of the premises guarantees the truth of the conclusion. What does that mean? That means that in a deductive argument, if the premises are true, then the conclusion must be true. Or another way to put the same point, if the premises are true, then the conclusion cannot be false. How is it that the truth of the premises can guarantee this? It's because the conclusion of a deductive argument puts together or restates information that is contained in the premises without adding any new information about the world. Take this example. We've got our single premise here, Jack is a bachelor, and then our conclusion, Jack has no wife. The reason why Jack has no wife must be true if Jack is a bachelor is because the meaning of the word bachelor is unmarried man. You can't have a wife and be unmarried. You can't have a wife and be a bachelor. Therefore, if Jack is a bachelor, Jack has no wife. The conclusion of this argument makes explicit something about the meaning of bachelor, rather than telling us something new about Jack. Because the truth of the conclusion depends solely on the truth of the premises, given conventional linguistic meanings, the conclusion contains no new information about the world. It is this fact which is the key to why deductive arguments can always guarantee the truth of the conclusion when all the premises are true. Obviously, such arguments don't guarantee the truth of the conclusion when the premises aren't true. For example, if Jack isn't a bachelor, we can't conclude with certainty that Jack has no wife. However, if Jack is a bachelor, if that premise is true, then the conclusion must be true. The conclusion of a deductive argument might be an instance of a general principle that is stated in the premises. Take this example, where we've got a universal generalization on top. Addition is commutative. That is, the reordering of the terms added doesn't change the value of the sum. Based on this general principle, we can conclude that 3 plus 4 equals 4 plus 3. Again, to see that the conclusion cannot be false if the premise is true, we need only understand the meaning of the premise and understand that the conclusion is an instance of this principle at work. Another way the conclusions of some deductive arguments follow depends on the connections drawn among the premises by important logical terms, such as and, or, not, all, and some. Let's look at some examples of that. Let's start with this one, with our friend Jeb from an earlier lecture. Either Jeb is not graduating, or he has paid his tuition bill. Jeb is graduating, therefore, he has paid his tuition bill. All right, let's look at this first premise here. We've got the conjunction or here and a claim on either side. So we've got two claims. The first one, Jeb is not graduating. The second claim, he has paid his tuition bill. What we get by adding in the either or is a bigger general claim that at least one of these things is true. Either it's true that Jeb is not graduating, or it's true that he has paid his tuition bill. They can't both be false because at least one needs to be true. So that's the first piece of information we have. Now we get the second piece of information, namely that Jeb is graduating. Well, if Jeb is graduating, it's certainly not the case that Jeb is not graduating. That's just a contradiction. So, assuming we're talking about the same graduation, and we are. So if this is false because this is true, then this second part has to be true. It has to be the case that Jeb has paid his tuition bill. And that is what the conclusion says, that he has paid his tuition bill. The reason this conclusion can't possibly be false if these premises both are true is because the information contained in the premises combined necessitates the truth of the conclusion. Okay, take a look at this example. All whales are mammals. All mammals are warm-blooded. Therefore, all whales are warm-blooded. Now what's going on here is neither premise on its own shows that this conclusion must be true, but the premises combined show that it must be if both of these premises are true. If you're looking at this argument, it doesn't seem obvious to you that this conclusion has to follow if both these premises are true. Let's try taking a pictorial look at what's going on here. Okay, so in this argument, we're talking about three different classes of things. We've got the class of things that are whales, the class of things that are mammals, and the class of things that are warm-blooded. Often, when you've got arguments that use words like all and some, it's useful to do a Venn diagram sort of thing, where you're mapping out the relationships between different classes. Let's start with a circle for all the things that are mammals. What we've got going on here is the claim that all whales are mammals, which means all the whales are going to fall under the class of mammals. So if this represents the class of whales, this represents the class of mammals. All the things that are whales, all the things that are members of the set of whales are going to be members in this greater set, the set of things that are mammals. Okay, so that's how we map out a picture of this first premise that all whales are mammals. What about the second premise? All mammals are warm-blooded. Well, if all the mammals are warm-blooded, if we've got a circle that represents all the things that are warm-blooded, all the mammals need to fall inside that circle as well. Okay, so now we've got the situation where we can see that all whales are mammals and all mammals are warm-blooded. Therefore, we've got our conclusion, all the whales are warm-blooded, i.e., all the whale things fit inside the warm-blooded things class. And that's just what our conclusion says. Okay, let's look at this example. All men are mortal. Socrates is a man. Socrates is mortal. So once again, we've got this all claim here that's talking about a set, the set of men, that they fall inside another set, the set of mortals. If you're a man, then you're mortal. Not necessarily all mortals are men, of course. You know, take your dog, for example. Presumably immortal, if you don't have an immortal dog, but not a man. Then we've got Socrates as a man. Now we've got a claim about a particular, that this particular is part of this class, the class of men. And from this we can conclude that Socrates is mortal. If we wanted, we could have done another picture. The set of all things that are Socrates, which would just be Socrates, that's going to be inside the set of all things that are men, and the set of all things that are men are going to be inside the set of all things that are mortal. So this first premise, which is a universal generalization, it contains the information that all members of one class or type of thing, the class of men, are also members of another class, the class of mortals. Then the second premise provides information about the individual whose name is Socrates and is a member of a class of men. And from there, the conclusion of the argument combines the information contained separately in the two premises. So strictly speaking, the conclusion contains no information not already presented in the premises. But it's important to note that neither premise states explicitly in just those words what is said in the conclusion. The information in the conclusion is implicit in the premises. This is a trait that all deductive arguments have. If all deductive arguments were simple enough that one could easily see that the conclusion is true just by looking at the premises, there wouldn't be much point in doing deductive arguments. But deductive arguments are not always simple, and the conclusion's often not obvious. Take, for example, a complex proof in geometry. These arguments are deductive, and the conclusions are often not obvious. Take this other example from a conversation. Jones, you spend 3 weeks a year on a commuter train. 3 weeks a year? That's ridiculous. Smith's response. You ride the train to and from work 1 hour each way, 5 days a week, for a total of 49 weeks a year, allowing for your vacation and holidays. Using simple arithmetic, that comes to a total of 490 hours per year. There are 24 hours a day, and if you divide 490 by 24, you spend 20 and 10/24 days on the train. That's almost 21 days, or 3 weeks a year, that you spend on the train. So what we've got here is the conclusion out front. Jones, you spend 3 weeks a year on the commuter train. Jones, even though he knew all the facts that Smith cited down here, still thought this was a ridiculous conclusion. In essence, the information that Smith goes on to cite, which Jones possessed, contains the piece of information that Jones spends 3 weeks a year on the commuter train, but it's not at all obvious that it contains this. Smith has to go out step by step and show it to be so. And that's often what's going on in deductive arguments. You've got to sort through the different pieces of information. You've got to look at the relationships that hold between the pieces of information, and only then can you start to find some novel conclusions deductively. Because in a deductive argument, if the premises are true, the conclusion cannot be false, certain words and phrases naturally mark the strong support provided in these arguments. Expressions such as must, it must be the case that, necessarily, inevitably, certainly, and it can be deduced that frequently indicate that an argument is deductive. The terms entail and imply also signify a deductive connection between premises and conclusion. Just as with indicator words for premises and conclusions, you still need to actually assess the argument to see whether or not it's deductive or not, because these indicator terms are not completely reliable. For example, sometimes these words are used as part of strong inductive arguments, that is, arguments that are strongly supported by the conclusion, but in which nevertheless the truth of all the premises is compatible with the falsity of the conclusion. A better test to tell whether or not an argument is a deductive argument is to ask the following question. Is it impossible for the conclusion to be false if the premises are true? You can check this by imagining that all the premises are true. If all the premises are true, must the conclusion be true? Step back, think about the premises one by one, imagine that they're all the case. If it has to be the case, if they're each true, that the conclusion is true, then the argument is a successful deductive argument. If there's a way for all those premises to be true and the conclusion to still be false, well, then you don't have a successful deductive argument. In philosophy, logic, and critical thinking, a deductive argument is a technical term. Only arguments in which the truth of the premises guarantee the truth of the conclusion count as deductive. In other settings, talk about deduction is often used more loosely. For example, in Sir Arthur Conan Doyle's stories, when Sherlock Holmes claims to deduce something, he often is merely using strong inductive reasoning. Take the following instance where Holmes claims to have deduced that Watson was practicing medicine again on the following grounds. As to your practice, if a gentleman walks into my rooms smelling of iodoform, with a black mark of nitrate of silver upon his right forefinger, and a bulge in the side of his top hat to show where he has secreted his stethoscope, I must be dull indeed if I do not pronounce him to be an active member of the medical profession. What's happened here is Holmes took a set of physical evidence and turned it into premises, including the fact that Watson smelled of iodoform, he had the black mark of nitrate of silver on his right forefinger, and that there was a protrusion in the side of his top hat where he was hiding his stethoscope. From this, Holmes sensibly concluded that Watson was practicing medicine again, but he didn't deduce it in the technical sense. It could have been the case that Watson smelled of iodoform, had a black mark of nitrate of silver on his forefinger, and had this bulge in his top hat, but wasn't practicing medicine again. There could have been some other explanation. It's just that he was practicing medicine again was certainly the best explanation. So what we had going on here was a case of what we'll be calling inductive reasoning. And we'll be talking about that more next time.